Hello and welcome to I.Q-man. Today we are going to see what are chemical bonds and electronegativity and what is valency. What is valency? Valency is the number of chemical bonds an atom or ion can make. It is also the number of electrons an atom or ion can share, lose or gain to reach a full outer shell. A very simple formula is used to find the number of electrons in a shell, which is E is equal to 2n square, where E is the number of electrons and n is the shell number. Here is a small table which displays the shell number and the maximum electrons it can hold. Electrons don't fill in the order of the shell number. This means that the third shell can gain electrons even before the second shell is completed. They have a different way of filling through subshells. Due to this, the valency of any element except hydrogen and helium is considered 8. It is really common for substances to have different valencies depending on the substance they react with. Sulfur, a non-metal, has a valency of 6 in H2SO4 sulfuric acid and a valency of 4 in SO2 sulfur dioxide. Chemical bonds. Atoms of a substance tend to be in a stable and low energy form. This means that they wish to gain or lose electrons to have a full outer shell. That's why they form chemical bonds. It's easier to live with someone than to live alone. The noble gases don't form much compounds as they already have a full outer shell. On the other hand, halogens and alkali metals react violently with other substances as they only require to gain or lose one electron to stabilize themselves. Types of chemical bonds. All atoms have a property called electronegativity. This is how strongly an atom pulls electrons from other atoms. Every atom shares, loses or gains electrons, which is known as a chemical bond. You can imagine it as a tug of war, where on both sides an atom is pulling for an electron. The type of chemical bond can be figured out by a very simple formula. The electronegativity of atom or ion 1 minus the electronegativity of atom or ion 2. Due to the modulus bar, the answer is absolute and does not have a sign. Example: iron has an electronegativity of 1.88 and oxygen has an electronegativity of 3.04. So, if we apply modulus bars and if only, 1.88 minus 3.04 is equal to 3.04 minus 1.88, where the answer is 1.16, where it has no sign, neither positive nor negative, it's absolute. But 1.88 minus 3.04 is not equal to 3.04 minus 1.88, as negative 1.16 is not the same as positive 1.16. Types of bonds. Ionic bonds. When an atom or ion loses electrons and another gains them, they form an ionic bond. This happens through an oxidation-reduction reaction. This happens when the difference in electronegativity is more than or equal to 1.7. Basically, an atom or ion pulls an electron so strongly that it pulls it out. Also, some atoms like lithium want to get rid of their electrons eagerly that they barely have any electronegativity. Covalent bonds. When two atoms or ions share electrons, the bond is said to be covalent. This happens if the difference in electronegativity of two atoms is more than or equal to 0 but less than 1.7. For example, the electronegativity of carbon is 2.55 and oxygen is 3.04. So 3.04 minus 2.55 or 2.55 minus 3.04 in module bars is equal to 0.49. So 0.49 is more than 0 but less than 1.7. So each oxygen atom, not the whole O2, has a covalent bond with carbon. In such a bond, the electrons are shared instead of lost or gained. Let's have an example: SO4, sulfate. In this case, we'll consider both valency and electronegativity. Always remember, atoms and ions tend to be in a less excited state. So when sulfur reacts with the first oxygen molecule, the bond is covalent with a difference of 0.46. Oxygen has a valency of 2 and sulfur has a valency of 4. Electrons are shared, leaving their valencies as 0 and 2 respectively. Same goes for the second one. When the second oxygen atom shares 2 electrons with sulfur, the valencies are 0 and 0 and the bonds are still covalent. doesn't matter how many bonds form, they'll always be covalent, as the difference will always be 0.46. When the third oxygen atom reacts with it, the valency that was 4 changes to 6. It's very common, as I said, for elements to change their valency depending on the number of bonds they form and with what they form the bonds. The valency is 0 again after cancelling out. When the fourth atom reacts, the valency of sulfur is still 0. The number of electrons gained by each oxygen atom isn't the same. Two atoms get 2 electrons and the other two only get 1 electron. Effect of valency on chemical reactions. Valency makes chemical reactions easy. We can find the number of atoms or ions required to make a molecule by their valency. This is done by exchanging their valencies and writing it in the subscript. Example: oxygen with a valency of 2 and hydrogen with a valency of 1 react together, switch the valencies for the subscript. A hydrogen with a valency of 1 and oxygen with a valency of 2 give H2O1. So the answer is H2O1 or just H2O. Let's have an example with an ion, sulfate, an ion with a valency of -2, and sodium, a metal with a valency of 1. React together, switch the valency for the subscript. Sulfate as a whole has a valency of -2 and sodium as a whole has a valency of 1. So their product is Na2SO4 1. So the answer is Na2SO4 1 or just Na2SO4. Remember, sulfate is as a whole and not separately as sulfur or oxygen. So thank you for giving me your time and watching the video. I'll see you soon in my next one.